Hi, Ken Assistant here. I just finished adding a new other lab analysis report. These are located here, and these are intended for people who don't have a 16-ounce lab. They have an older technology, often by cultivating bacteria lab results. It's not as ideal, but you have the data, and what we're going to try to do is make use of as much of the data as you have, and we went from there. Okay, so what we are going to do is go down and look at this German report, and if I click on it, you will in a moment see all of the bacteria which are reported in the report. Some of these you'll find maybe only in 12 or 18 items. Others you find in massive lists. This is one of the bigger lists. So what we have here is we have all of the bacteria which, or in some cases tapeworm, whatever, which is in the variety of reports. Now, what we end up doing is transcribing data from one of the from the report over to this page. But to understand how we transcribe it, you should be aware of something. If you go in the range, we have basically very low, low, in range, high, very high. Okay, this corresponds roughly to what is reported on the report. Let's take a look at this particular report. Here's the report, and we have all sorts of measures on it, some of which are not of interest to us specifically. It's their attempt to estimate things like acetate propionate production. We do our own estimation of that based on 16S samples, but we cannot do that from these type of reports. But we do have how much of everything is, and you notice that in general you have a green, which means it's in the range. You have a yellow band, which indicates slightly low, and then you have a red band, which means majorly high or majorly low. So these are what we use to indicate what value you are. For example, the first one here, you have it very low, so the result is you would probably pick 2 down arrows on the entry form. Up here you have very high, you probably pick 2 up arrows on the entry form. So that is basically how we transcribe. It's the 2 down arrows, 1 down arrow, check mark, 1 up arrow, 2 up arrows. Very straightforward combination. What we should be aware of is the numbers here may not always be compatible with what is reported in a 16S report. Different methodologies are used for each lab. Even if they are using a 16S report and only giving you some of the data, how they process it makes a major impact on what is coming up. It's all of the frustrators dealing with the microbiome, which is we have a lot of cooks, a lot of labs, a lot of smart people thinking they have the best solutions in the kitchen. Okay, let's go back and take a look at the entry. So we just go in and we mark things as we did before, and then when you click the magic analysis button, and we now have the ability to get suggestions basically on the information you've just entered. I won't go over in detail. You can select what type of things you want, how many items you want to do it. You can be very strict saying, okay, if it's not explicitly cited in a study, we don't use it. If you want to be more relaxed, you can say, okay, wait a minute. If this impacts the child of a particular bacteria, I want to have it included, or other ways of getting suggestions. So we have a whole variety of choices, which I won't go over. What I want to do is hop over and look at how we get choices. And how we get choices becomes a little bit tricky. The reason it becomes tricky is the lab's usual convention, because they are a general purpose labs and not specializing in the complexities of the microbiome. What they would do to get their values is run the same test on a bunch of apparently healthy people who happen to live in the same area as the labs. From this information, they get the average and standard deviation, which is seen in each measure. And from that, they do simple mathematics, naive mathematics, and calculates what the upper and lower bounds should be. Now, a different lab will have different values. And they may use the identical same method. It's just that one may happen to be in Germany, and the other one happens to be in Mumbai, India. One has a large number of meat eaters, and one has a large number of vegans or vegetarians. So the difference is that the averages are going to be significantly different. Very different, in fact. Okay, so getting back to more mundane things, Jason down in Australia is known by many people for producing very good numbers for what should be. I have gone and copied his table here, but I have for each value put in the range which this particular lab suggested. As you can see, this lab suggests 27 to 36. Here we have a much bigger range. Akkermansia suggests it should be a low value, much higher value. And you have this disagreement often all the way through many, many things. This one, hey, it shouldn't be over 2.3%. Jason says, fine, up to 15%. Disagreement, professional disagreements. And then in other areas, we have some real bizarre things, like the range is 1.9 to 5 is what the lab deems to be healthy. The range goes from 10 to 15, double the highest value, triple the highest value, in which case you have a professional disagreement. So when you are entering the value, you should be looking at the value, seeing whether or not there is an issue with the value according to people like Jason or other people you trust to provide you reasonably good content. The other thing you want to do is to hop over, and we'll go back to the screen before this one. We'll just do a back arrow. And all the way up and down here, you will find that everything is linked. Like, for example, here we have this one. Just open it in a new link and take a look at it. And the main thing here is to help you decide, are your values really abnormal, or is this some fluke with the lab and how they're doing samples? So a moment we will see the values here. So for example, we'll be looking at this particular one, the Walsworthia. You'll see the lab says 0 to 1.86. Jason says 0 to 0.25. Value is 0.45. So we're going to hop over and take a look at the actual details by clicking on the link to it. And now we have a log value, which doesn't help us greatly at the moment, but we're going to convert it to percentage. And once we convert it to percentage, you see what the distributions of values are. Now let's go back and take a look at what the range of numbers we are. We are basically looking up to a value of 0.25 or 1.89. So let's take a look at 0.25 first. And if you go along here, we find that 0.25 takes us up to the bottom 48% of samples. In other words, half the people would be abnormal, half the people will be deemed to be healthy. Let's take a look at Jason's numbers. Jason's numbers, actually, sorry, wrong tab. That's So half people will be unhappy here. The 1.89, which is the lab result, we go along here at 1.89. And what will happen is we find that covers about 95% of the value seen. In other words, one of the ranges will make half the people unhealthy, or deem half the people to be unhealthy. The other range of values will deem less than 3% to be unhealthy. So the question is, where should you deem yourself to be unhealthy or not with this value? Let's go back and take a look at this value once more. And the actual value which we are dealing with is 0.45. Let's see where that is on the chart. We just go along here until we find 0.45. And we find that sitting there. So we are at a value where 67% of people have less and 33% of people have more. My own reading of it is very simple. You have a typical value. No issue. You're not abnormal. Now, the same thing, unfortunately, will need to be done with just about every single item here to figure out how you should mark it. That means walking through and checking them, etc. I should mention one other thing is sometimes you may not find the bacteria as you know it on the list. Watch out for things like here. If you click on something like this one, it will take you over and where all the different names that this bacteria has been given are listed. The problem which we have is some studies will use one name, some studies will use the other name. There is a magic number, what's called taxon number, which is unique. But for readability, we have to often go in and update it with the appropriate one. Sometimes it's a little bit of work to figure out which one it should be. But in this case, from experience, I know it's probably this one. If you are unsure, you can go over and use some of these lovely cross-references. My usual reference is usually going across the DataPunk first. And it will use the same number, which this case is 5476. And so I picked the wrong name. 5746 is usually known as that one, so I simply go back and update the name to be what it is. And now we are effectively done. You will find down the bottom the chart showing what the expected range is. In this case, we find that we actually have nothing in our 16S samples with the values. So the only thing you can do is work with the lab values. The modifier base is generic, so it will not depend on whether or not it's reported in 16S. It simply looks everything up. Okay, I think at this point of time I've covered most of the items. The handling the other lab analysis here is more complicated than a 16S, and that's because every lab does its own values. Labs measure things differently. Comparability between one lab and another all becomes nightmarish. So there's no easy solution apart from yourself walking through. Remember, you can always find information about what the observed distribution is in over 1,000 samples. Most of the time, labs only use 100 samples, which means we have a much more accurate picture of what the range of expected values seen in a population is. Usually not a problem unless you are in the top high 5%, or if something that everybody has and you have nothing, then if you're in the bottom 5%. Okay,